All right, so then here, same thing. I'll do these ones a little bit quicker, right? So if you look at one of the last video, I'll kind of go through things in a bit more depth. So if I factor, right, this bottom is easy to factor. I can pull out a value of x. This top one, let's see, I'm probably going to get a 2x, and in x, I'm going to get a +1 and a +1 right there, right? 2x times 1 is 2x, 1 plus x is x, 2x and x give me 3x, right? So that's our factored form. So let me find my domain restrictions first. So I'm going to check out where my denominator is equal to 0. So I'd get a x equals 0 and a 2x plus 1 equals 0. So this is going to be -1/2. So I know my domain is going to be all real numbers except for 0 and -1/2. So now I'm going to do a little bit of canceling, right? Notice that this 2x plus 1 and that 2x plus 1 cancel. So my new simplified function is x plus 1 over x. All right, so when I kind of look at classifying these things, notice that this 2x plus 1 canceled out completely from the denominator, so that's going to be a whole. So we're going to have a whole when x is equal to -1/2. Notice that this x did not cancel out completely, so that's going to be a vertical asymptote. So x is 0. If I want to find the y coordinate of my whole, I'm just going to take this x is equal to -1/2. I'm going to throw it in to my most simplified function. So if I do that, I'm going to end up with -1/2 plus 1 over -1/2. So it's going to be 1/2 over -1/2. That's going to be -1. So I get this as my whole. If I look at this one below it, so I can factor this numerator, right? This is a difference of squares. This is something easy to square root. This is something easy to square root. So I'm going to get an x squared minus 9 and another x squared plus 9. X squared minus 9 can factor again. That's another difference of squares. So we get that. So then, once again, I want to find my domain restrictions. That's going to occur when my denominator is equal to 0. So x minus 5 is equal to 0. That gives us x equals 5 as a domain restriction. X plus 3 is equal to 0. So we're going to get an x equals -3 as a domain restriction. So now we're going to do some canceling. This x plus 3 and that x plus 3 are going to cancel out. It's going completely out of the denominator, so that's going to end up being a whole. This x minus 5 doesn't cancel, so that's going to be a vertical asymptote. So my most simplified version, I have an x minus 3 in the top. I have an x squared plus 9, which isn't going to factor over the real numbers. And I have an x minus 5 in the bottom. So my vertical asymptote is going to occur when x is equal to 5. To find the y coordinate of my whole, I'm just going to take my function, and I'm going to plug in x is equal to -3. All right, so that's going to give me -3 minus 3, -3 squared, be careful with parentheses, plus 9, all over -3 minus 5. So this is -6. This is going to be 9 plus 9. That's going to be 18. And I have a -3 minus 5. So that's going to be a -8 in the bottom. What can we cancel, right? So there's like a 2 that goes into that. So that's going to be a -3. There's a 2. Wait, that's going to be 4 when I leave that over. Then I can divide that 2, 9. So -27 over 2. So -3, -27 over 2 would be the whole for that function. And finally, there's the last one. So I actually can factor this top, right? This would actually factor into x plus radical 3, x minus radical 3. So that would be like a simplified form. If I look at this denominator, does this factor nicely? No, because there's no factors of 4 that are just 1 away. This does not mean that we don't have any issues in terms. It just means that we can't really factor it. So could this thing equal 0? So let's see. Is x squared plus x minus 4 ever equal to 0? Since it doesn't factor, well, it's time to either complete the square or do the quadratic formula. Since most students would just go to the quadratic formula, I'll do that one. So remember quadratic formula, -b plus or minus the square root of b squared minus 4ac all over 2a. So if my a is 1, my b is 1, my c is -4. All right, so let's see. I'm going to get a -1 plus or minus the square root of -4. Square root of -4 squared. That's going to be a 16 minus 4 times 1 times 1. So that's going to be okay, times 2 times 1. So we're going to get -1 plus or minus the square root of 12 over 2. This square root of 12 we can simplify into radical 4 radical 3, which would be the same as -1 plus or minus 2 radical 3 all over 2. So those are going to be places where our denominator is equal to 0. Notice that this right here is not, whoops, that's an eraser. Notice that this right here is not equal to either positive or -3. There's going to be no cancellations. Nothing's going to factor out. So we're going to have two vertical asymptotes. One when x is equal to -1 minus 2 radical 3 over 2, and another one when x is equal to -1 plus 2 radical 3 over 2. There are no holes, thankfully. And you can actually kind of use this as your most simplified version, because I would argue that this doesn't, by factoring this way and factoring a denominator to like roots like that, you're not doing anything easier. So I would just kind of keep it like this. All right, so again, all we care about is holes of vertical asymptotes. And in this case, we're able to figure out where holes in vertical asymptotes are by looking at when our denominator is equal to 0 and what cancels.